A measure of central tendency is a single score that represents an entire distribution. When you're going to be, when you're doing a study, if you're taking a sample, you're going to have a lot of data. And so you're not just going to have one single answer. You're typically going to be collecting data from quite a few people. So you could have, let's say you've asked people, how many courses are you taking this semester? And so some of them say 3, and some say 2, and 4, and 5, and 6, and 3, and 3, and so on, and so on, and so on. And so you've got a lot of different individuals responding. If you'd like to present your findings to another person, they're not going to be interested in looking at every single data point and trying to take that in. In fact, even if they were interested, it would be a bit challenging to keep track of all of that data and keep a sense of exactly what the values were. So instead, we try to summarize all of this in just a single value. And we think of this, we want this to be a single representative, or a single value that is typical of this whole distribution. We do this in real life all the time, just without even thinking about it. Let's say you go to a restaurant and you go try a new restaurant for the first time, and then you're telling your friends about it, and they say, okay, well, how expensive was this place? There were probably about 30 different things on the menu that each had their own price. They're not asking you to list off the entire menu with every single price. They just want to know, in general, were items about $20, $30, $50, $100. So they're asking you to find a typical value. They're not expecting you to give every single value, and they're not expecting that the answer that you give is perfectly representative of every single one of those values. If I tell you that there's a restaurant where entrees are about $25, don't be surprised if there's something that's $23 or $32. 25 was just sort of a typical value to give you a sense of what's going on. So that's what central tendency does. It gives us a quick sense of what's going on with an entire data set. So pretty simple, right? Well, unfortunately, things do get a bit complicated. Now, you're going to be introduced to not one, but 3 different measures of central tendency in the course, or at least in this chapter. And the first is going to be the most important. It's called the mean. And the mean is just a fancy word for what you think of, or what you already know as the average. So the mean is the average. That just means add everything up and divide by the number of things that you added up. Just the way we find an average in everyday life. So the mean is not only the most common to see throughout the entire course, it's one of the most intuitive, and it takes into account every single one of your values. If I have 3 values, 3 plus 4 plus 5, I have to add them all up to get my total. So 3 plus 4 is 7, plus 5 is 12. So my total is 12. To get the average, it's going to be the total over the number of values that went into that total. And so I have 12 over 3. The average is 4. 4 is our excuse me, our measure of central tendency. It's a typical value for this distribution. So that's the mean. But the mean is not used throughout the entire course. Sometimes we're going to use other measures of central tendency, like the median. The median just means the middle value. What is a middle value? Well, if you have a set of data and you put them in order, like I just put these in order without thinking, the middle value is the median. You won't always be presented with your data in order. You could have something like this. It could be 5, 3, 1, 2, 4, 0, 6. So you have to put them into order. 0, 1, 2, 3, 4, 5, 6, and then you find the middle out of all of these. And so the middle is going to be right there. This is my median. It's the middle value. There are as many values lower as there are values that are higher. So sometimes we use the median as being our typical value. And then finally, the last one that you're introduced, at least in this early part of the course, is the mode. And the mode is the most frequent, or the most frequently occurring value in your data. Now, there is no mode for that first example that I gave, but if I had data that looked like this, let's say I had 1, 3, 5, 5, 5, 7. Well, the 5s, they are not the median, they're not the mode, but they are the most commonly occurring value, and perhaps that's what you choose to say is typical. In fact, this is something that we do fairly often in everyday life as well. If you see a certain value keeps popping up, that might be how you express what's going on with the entire distribution. Okay, so why would we have 3 different measures of central tendency? Well, the simple fact is that each one of these is not necessarily appropriate to situations where the others might work. We do tend to try and use the mean throughout the course as much as possible. The reason for that is that the mean makes use of every single value in your data set. And that's something we like to see in statistics. We like to see that we're using all of the data. Whereas something like the mode, in this example I gave you here, if the mode is simply looking for the most commonly occurring value, what would happen if my data set was changed? What if instead of having 1, 3, 5, 5, 5, 7, what if I had 1, 2, 5, 5, 5, 7? The mode won't change. The mode is unaffected by that little change from 3 to 2. We don't really, this isn't considered to be a great way to perform statistics. If you have a measure of central tendency, it's better to see that you're involving all of your data. The mean does that. So the mean is our first choice, but it won't always be appropriate. There's going to be some distributions where the mean gives sort of a, not really a typical value. Maybe the best way to describe that, I think your textbook says that the mean is best used for symmetrical uniform distributions and for symmetrical unimodal distributions. So what does that mean? Well, symmetrical just means that it's the same on both sides. There's going to be a dividing line in the middle of your distribution where if you were to graph it, there's going to be a dividing line where it looks the same on both sides. And uniform means that your distribution is sort of evenly spread out. So let's say that I have something like a dice. When you look at a dice, the possible values are 1, 2, 3, 4, 5, 6, and the frequency with which those occur is the same across all of the numbers. So this would be a distribution where I have a uniform symmetrical distribution, and the average, in this case, would be appropriate. The mean works well to describe a typical value for a symmetrical uniform distribution. A symmetrical unimodal distribution would be something where there's a single mode. So if I've got my x-scores, that would look like this if I were to graph it out. So this is symmetrical. There is a dividing line here, and it's the same on both sides. There's a single mode, and so this would be another case where the mean is going to be appropriate. And actually, you're going to see a lot of this kind of distribution throughout the course. So we do use the mean quite a bit. In fact, the median and the mode don't get mentioned too much outside of this chapter. So when would we use something like the median or the mode? Well, the median is especially going to be used in situations where you have skewed data. Skewed data is a situation where you don't have symmetrical or symmetrically distributed data. You might have data that looks something like this, where it tapers off quite a bit. There is not a very high frequency of high scores, but there are high scores, sort of pulling the distribution up. You might see this sort of a distribution at in the payrolls at a company. A lot of people down here, a lot of people are paid a low wage, and very few people up here, so not a very high frequency. They don't have a high frequency. There's very few of them. We have a small frequency of highly paid individuals. So why would the median be appropriate in that case? Well, let's have a look at that kind of a situation with just a few people. Let's say you were to go to Microsoft and you are looking at people's salaries. So you take a quick sample and your salary happens, or your sample happens to include a few developers, so they're making 60,000, 80,000, 100,000, but then you've got the CEO, and so they're making $20 million. Now, in this case, if we were to take the average of all four of these, let's do that actually. Let me take the total here first. I'm going to do 60 plus 80 plus 100,000, and then I'm going to add 20 million. Okay, this comes out to be 20,240,000. If I divide that total by the number of values that went into that total, so if I'm just finding my average or my mean, if I divide that by 4, my average, the average salary is equals to just over $5 million. So this is the mean. There's nothing wrong with the way that I've done it. It's not a miscalculation. However, my average or my mean is no longer a typical value. 5 million doesn't really give me an idea as to what anybody in this company is making. There is a bunch of people that are making 100,000 or less, and then there's a single person who has a huge salary of 20 million. This number falls somewhere in between, in a place where there really are no employees in my sample. So this is not typical of my distribution. So when you have skewed data, when you've got some extremely high scores or extremely low scores, that's where the median fits in. Another place the median would fit in is if you're only interested in the relative sizes. Let's say you have a group of people and you want to find somebody who's a typical height. And so you line them all up from shortest to tallest, and you don't have a tape measure. So you can't actually figure out what their actual heights are. But you can line them up from shortest to tallest, figure out which person is in the middle, and you could say that person is a typical height. They might not be exactly the average, and there is no mode. There's no two people that have the same height, but it's easy to figure out where the middle is. And so the median could be used in that sort of a situation as well. In a situation where you don't actually have numerical data, but you can put your data into order. What about the mode? Well, the mode, I think I've already touched on this one. There are going to be situations where a number occurs quite often. Perhaps a certain answer occurs quite often. Maybe if you did a survey and asked people how many courses they're taking this semester, by far the most common answer would be that people are taking 4 courses per semester. That On its own, because it's the most commonly occurring answer, that could be the best way of describing what's typical. But the mode can also be used when your data is not numerical in nature. If I was to ask people something really simple like, what's your favorite color? And I got answers like red, blue, green, and purple. Well, I certainly can't take an average of these. I can't find the mean. I can't add them up and divide by 5. I can't take the median because how do I put these into order? But the mode is going to work perfectly here. This is when I have categories as my data. So you can see that we can't get away with just one measure of central tendency. We have to have these 3 to cover the situations that you're going to encounter in your stats course. And just to mention this once again, the mean is by far the most commonly used throughout the remainder of the course, so it's going to be one that you really have to have a good grasp of. So I'll go through a number of aspects of the mean, but I'll do the same to a lesser degree for the median and the mode in the following videos.